Hello, my name is Jack Boulay, and I'm going to tell you about reflux reactions. So reflux, this is the short answer. Reflux involves the continual condensation of evaporated volatile particles such that they return to the container out of which they were boiled, for the purpose of speeding up chemical reactions, often organic ones. If you want to speed up chemical reactions, you can heat up the components. That much is obvious. But if you're using organic compounds, there is a risk. Organic compounds tend to be volatile, that is, they evaporate easily. So if you just put a volatile solution into an Erlenmeyer flask and start heating immediately, you will lose the volatile particles, and this will change the concentrations of substances in the solution. And that will skew any data that you collect. However, refluxing, as I said earlier in my short answer description, involves the continual condensation and falling of the volatile particles so that they never permanently leave the flask. And reflux reactions are very helpful for speeding up reactions occurring in solutions with organic compounds because those compounds tend to react very slowly. So speeding up those reactions is very important. Now I'll tell you how you would construct the mechanism for a reflux reaction. In the hood, you would place a round bottom flask filled with the solution into a sand bath or some other heating mechanism. And you could also put a stir bar into the flask as well to help with even heating, but don't start heating it just yet. You're going to use a clamp to attach a condenser. Here's the clamp to attach a condenser, one with both arms far apart, to the top of the round bottom flask. Also stabilize the condenser with the clamp attached to the ring stand. To the lower arm, attach a hose connecting it to the water spigot, and to the higher arm, connect a hose and let the water drain into the appropriate sink. So the water is going to be flowing in this outer chamber of the condenser, and it's going to be flowing against gravity. And by having this constant flow of water in the outer chamber of the condenser, you're cooling the inner chamber and anything that passes into it, so that when the volatile particles evaporate and try to escape out of the round bottom flask, they have to travel through the condenser, and when they reach the condenser, they're going to cool down significantly and fall right back into the solution. And again, this is also that chemical reactions that might take place within the solution can occur faster, because chemical reactions occur faster at higher temperatures because all the particles in the solution are interacting far more frequently. Now here are the thou shalt nots of refluxing. Firstly, do not cover the top of the condenser. If you do this, pressure could build up and the whole thing could burst. Do not switch the positions of the hoses. If you do this, the condenser won't fill up all the way, and you won't get as great a cooling effect. And thirdly, and I don't have this here, do not do this outside of the hood. Remember, this isn't a perfect technique. It is possible that some particles could escape anyway, and you don't want to inhale those. And these particles that do escape, although there are fewer of them, this is the reason why you don't want to cover the top of the condenser, because if you cover the top of the condenser, then pressure could build up, as I said before, and the whole thing could burst because of those particles that do escape. So I hope this has been helpful, and thanks for listening.